This new unit is all about radical functions, and today we're just going to have like an introduction and some refreshers on what we already know about radicals. So the first thing that we want to do is we want to list all the perfect squares, cubes, and fourths. And keep in mind that, a square root is the opposite of squaring something. If you square 2, you get 4, and if you take the square root of 4, you get 2. These are called inverse operations. So knowing our perfect squares will help us with taking square roots of numbers. So we're going to list perfect squares, perfect cubes, and perfect fourths. I want us to list the first 10 of each. So to find those, what we do is the first perfect square is 1, because 1 squared is 1. Then 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100. For now, we're just going to do the first 10 of each. So then perfect cubes, that's when you multiply something by itself 3 times. So 1 cubed, 1 times 1 times 1, is just 1. 2 cubed, so 2 times 2 times 2 is 8. 3 cubed is 27. You can always type these in your calculator. The next one is 64, 125, 216, 343, 512, 729, and 1000. Finally, we're going to do perfect fourths. So this is a number to the 4th power. So 1 to the 4th power is 1, 2 to the 4th power is 16, 3 to the 4th power is 81, 4 to the 4th power is 256, 5 to the 4th is 625, 6 to the 4th is 1296, 7 to the 4th is 2401, 8 to the 4th is 4096, 9 to the 4th is 6,561, and 10 to the 4th power is 10,000. Okay, so anytime that you need these lists, you can look back at your notes here, or you can always just reproduce this list on your own. So if you're taking the ACT or you're taking a test from me, the first thing I would do if it has radicals on it is list out my perfect radicals. Because making this list doesn't take much time at all. All right, so when we talk about radicals, sorry, I skipped a slide. When we talk about radicals, we're talking about like the square root symbol, but the square root symbol, the radical symbol, it identifies cube roots and 4th roots and 5th roots and 6th roots and infinity roots. So we need to know how to read them. The nth root, so for example, the 8th root of a real number a can be written as the radical expression, the nth root of a. That's how you would read this, is the nth root of a. So the n is called the index. That's what that part is called. This guy, or little check mark, is just the radical sign. It's just a symbol. And then A, the number under the radical, is called the radicand. And we probably know this already, but when there is no index, it is assumed that n equals 2. So it's assumed that it's the square root or the second root or whatever you want to say. It's assumed it's the square root if there is no index given. So all that being said, let's dive into a few example roots. They're set up in this grid fashion on purpose. We're going to look at some stuff on these. I'm going to actually work these out. I'm going to do this one, this one, and this one, and this one. And then you'll do the others. So here we go. The square root of 16. This one's all possible roots. And that's important because the square root of 16 can be 4. But if you square negative 4 times negative 4, that also gives you 16. So positive 4 and negative 4 can be roots of 16. And we write that as plus or minus 4. So if we hop over here to 289, this is when you should look back. You can type these in your calculator. Square root button, 289, done. And actually, we only went up to 10s on our list, so you don't have this one on your list. If you were to go to 20, like 20 squared, you would have 289 on your list. But if you use your calculator, the square root of 289 is plus or minus 17. Because once again, if you multiply two negatives, you get a positive, and that would also, so negative 17 squared would be 289. The next one we're going to look at is here. This is the cube root of 343. So if you type this in your calculator or look at your list, you'll see that the cube root of 343 is 7. And we want to ask ourselves, can it be negative 7? And the answer is no, because 3 is an odd number. So if we had negative 7 times negative 7 times negative 7, that's 3 negatives. That's going to mean a negative answer. And it's not the cube root of negative 343. It has to be positive. So our 7 has to be positive. Now when we go down here, I want you to keep in mind that when you take the square root of a fraction or any root of a fraction, you're allowed to break it up. You're allowed to take the root of each of those. So if we look at this, we can assign the negative to whichever one we want. But like we just saw in the other cube root example, if we want to get a negative under here, our root has to be a negative. And then the cube root of 1 is 1. And the cube root of 27 is 3. And if we were to type in our calculator or do in our head, negative 1/3 times negative 1/3 times negative 1/3, we would get negative 127. Okay, the fourth root of 1, you can use your calculator or you can use your list, is 1. Can it also be negative 1? Let's find out. Negative 1 times negative 1 times negative 1 times negative 1. That is 1, 2, 3, 4 evens. And we know that 2, or not evens, 4 negatives. We know that 2 negatives make a positive, so that's really 1 times 1, which is positive 1. So, yes, this can be a negative 1, and we see that there is a pattern that if we have an even index, then it can be a plus or a minus for the root. So last one we're going to do is this 4096, and then you're going to fill in all the rest of them. The fourth root of 4096 is 8, but because this is an even root, it can be positive or negative. All right. So using this pattern, you can pause here, finish the rest of those. Using this pattern, we're going to fill in this chart to kind of just help you visualize what roots should look like. So if we have an even index, remember that's this part, and a positive radicand. So let's find an even and a positive. So that's easy, this one. The index is 4, the radicand is positive 1. The types of roots we got, are they real or are they imaginary? They are real. Positive 1 and negative 1 are both real numbers. So we do get real roots. And there are 2 of them. There's a positive and a negative. So now for the next one, we want to know if you have an odd index and a positive radicand, what do you get? So odd and positive, that looks like this. So we have a cube root of 343. We got 7 is a real number, and there was only one of them. So up here, we're also going to put the signs here just to help you. So if there's two roots, it's plus or minus. If it's odd and the radicand is positive, then your root is also going to be positive. If it's odd and negative, that is like this guy, and we still get a real number, and we still only get 1, but this time it's negative. And then finally, if we have an even index and a negative radicand, we don't have any examples of that, but that would be like saying the square root of a negative number, and when we have a square root of a negative number, we get imaginary roots, and we get 2 of them. We get a plus or a minus. The next section of your notes talks about simplifying radicals. So real quick, it gives you a note. It says if a radical has more than one root, so if it's an even index, then the radical sign indicates that's supposed to say only, the principal or positive root. So it's kind of like saying this is the most important root. Or the traditional one. It's called the principal root, and it is the positive one. So the difference is this here. If the radical symbol was already there, then don't change any signs. That's when it represents the positive root. But if you put the radical in, you have to include all possible roots. So if the problem says simplify the square root of 4, that just equals 2 because the radical's already there. That means it represents the positive or principal root. However, in version 2, when we have to solve for x, if we want to solve for x squared, we need to take the square root of both sides, because squares and square roots undo each other. So that's going to give us just x. And then over here, we wrote the radical in. It was not there before. So we have to put plus or minus 2. And if we look back and check our answer, if we plugged a positive 2 in here, we would get 4. If we plugged a negative 2 in here, we would still get 4. So either answer works, and we can't prove which one, like if it's just one or the other, or if it's both. So keep that in mind. If the radical symbol is already there, then leave the signs alone. If you put the radical in, you have to have all possible roots. All right, so the section that we're working on is simplifying radicals. So I'll do an example. We've already worked on simplifying square roots a little bit this year, so you should be a little bit familiar with this. Keep in mind, we just learned that if the radical is already there, we don't include both roots, we just leave it as it is. So we are just going to split this up, and you want to find the biggest number on your list of perfect squares, because this is an index of 2, so we're worried about squares and square roots. You want to find the biggest number that goes into 117 evenly. So if you look at that list we made, the 1, 4, 9, 16, 25, etc., the biggest number on that list that you can divide into 117 evenly is 9. And 9 goes into 117 13 times. So we can break this up to say the square root of 117 equals the square root of 9 times the square root of 13. And then we're going to simplify. We know that the square root of 9 is equal to 3, and the square root of 13 cannot be divided by any more perfect squares, so it can't be simplified. And we are just going to get for our answer 3 square root of 13. Okay? Now for number 3, it is a cube root, and it also has a number out in front of it. So if you remember from our reducing square roots section, we can just kind of separate everything. So we have 2 times the cube root of 48. And so when we simplify this, we're going to keep the 2. And then when we break up the cube root of 48, We want to look now at our perfect cubes list. So that was the one that went 1, 8, 27, 64, etc. And we want to find the biggest one of those numbers that goes evenly into 48. And the biggest perfect cube that goes into 48 is 8. So we will break the cube root of 48 down into the cube root of 8 times the cube root of 6, because 8 times 6 is 48. So once again, we're just going to keep bringing down the 2. And then the cube root of 8 equals 2. So we have another 2 here. And the cube root of 6 can't be simplified because 6 is not divisible by any perfect cubes. And once we get to the most simple form, then we just we multiply everything together. So 2 times 2 is 4. And things outside the radical cannot be combined with things inside the radical. So that's as simple as it gets. 4 times the cube root of 6. So another one is the cube root of negative 250. So anytime you have a negative under there with the cube root or any odd root, you want to bring the negative out with the perfect cube that you have. So the biggest cube root that goes into 250 is 125, and it's 125 times 2. But we want to get rid of this negative as well, so we're going to make sure to attach the negative to the perfect cube and not the one that's going to stay under the radical. So the cube root of negative 125 is negative 5 times the cube root of 2. And then that simplifies, we just write that as negative 5 cube root of 2. And then for number 7, it's the last example on this section I'm going to do. It's a 4th root. So we're going to split this up. We have 3 times the 4th root of 162. And this time we're going to look at our perfect fourths, 1, 16, 81, 256, etc. And the biggest number that from that list that goes into 162 evenly is 81. And 81 has to be multiplied by 2 to get 162. So bring down the 3. The 4th root of 81 is also 3. And then the 4th root of 2 cannot be simplified any further. So when we multiply this all together, we get 9 times the 4th root of 2. So here I would like for you to pause the video, complete the rest of problems 1 through 8 if you haven't already. Here are the answers that you should get. The next section talks about radicals with variables. So this is just a little bit different, but it's not too complicated. Let's just take a look. So this says that square roots, for perfect square roots, when you have variables, perfect square roots, the exponents must be multiples of 2. For cube roots, the exponents must be multiples of 3. And for 4th roots, the exponents must be multiples of 4. And the way that we simplify perfect roots is we're going to take the power divided by the root. So 4 divided by 2 is 2. That means that this equals x squared with no radical. In this one, 12 divided by 3 is 4, so this equals x to the 4th. And then finally, in the last one, 20 divided by 4 is 5, so this is just going to equal x to the 5th. And so I kind of just want to show you, I'll just pick out the cubed one, how this works. So if you have x to the 4th cubed, that means times itself 3 times. So when you multiply exponents, you add them together. So x to the 4th times x to the 4th times x to the 4th is going to give you x to the 12th, which is what we had under the radical to begin with. So now we're going to go apply that to some examples, but these examples are not necessarily going to be perfect roots. Number 9 is the first example we're going to do. So let's just break this apart into pieces. I think that's the easiest way to look at it. So let's do the square root of 32 times the square root of x to the 4th times the square root of y to the 9th. And we're just going to kind of look at each piece separately. So the square root of 32 is going to be reduced by dividing 32 by 16. So this guy is going to turn into the square root of 16 times the square root of 2. And then we're going to multiply that because we're just bringing down the multiplication symbol. The square root of x to the 4th, remember when there's no index, it equals 2. So 4 divided by 2 is 2, so that just equals x squared. Then we're bring down the multiplication symbol, and the square root of y to the 9th, this is where things are a little different. I'm going to actually bring it over to the side and show you separately. So we have y to the 9th, and we have a square root. So I'm going to show you how this works. You have 9 divided by 2 is 4 with some left over. So 2 goes into 9 4 times. So we get a y to the 4th, and it has 1 left over. So y to the 1st has to stay under the radical. So 2 goes into 9 4 times with 1 left over. Okay, let's look at that again. 2 goes into 9 4 times with 1 left over. So do you see where all the pieces to that go? So let's pull what we figured out over here back over to here. So y to the 9th breaks down into y to the 4th times the square root of y, because the 2 is understood and so is the 1. All right, so once we're not done simplifying because the square root of 16 is just 4. So we have 4 times the square root of 2 times x squared times y to the 4th times the square root of y. So we take everything outside the radical and multiply it together. So 4x squared y to the 4th. And then everything under the radical gets multiplied together under a radical. So your final answer is 4x squared y to the 4th times the square root of 2y. We're going to do a few more examples, so don't get too concerned. Number 10 is another square root. So again, the first thing that we're going to do is divide it up into sections. So the square root of 324 times the square root of a cubed times the square root of b to the 7th. So the square root of 324 is actually, it's a perfect square. So it's just 18. And then we bring down our multiplication. The square root of a to the 3rd. Remember, this is understood to be a 2. So let's just go ahead and put a and a square root and an a, because we know that there's going to be stuff left over because 3 is not divisible by 2. So 2 goes into 3 one time with 1 left over. Okay? And we know that those 1s are understood and don't actually have to be written. So we're just going to write this as a times the square root of a. Now, we bring down our multiplication, and we have the square root of b to the 7th. Again, understood to be a 2 here. Let's write the pieces. So we're going to have a b, and we're going to have a square root of a b, but we need to know the powers. 2 goes into 7 3 times with 1 left over. Once again, we know that that 1 is understood. We don't have to write it. So now, everything that's under a radical is as simplified as it can be. So we're going to take all the things that are outside the radical and multiply them together. 18ab cubed. And everything that's under a radical gets multiplied together under a radical. So 18ab cubed times the square root of ab is your answer. Okay, number 11 is a cube root. We're going to Do the same thing again. Split it into pieces. And we have the cube root of 216 times the cube root of m to the third times the cube root of n to the sixth. So the first thing we want to look at is the cube root of 216. 216 is actually a perfect cube, and the cube root is 8. Then we bring down our multiplication. And the cube root of m to the third, 3 is divisible by 3. So this is a perfect radical or perfect root, and it leaves us with no radical symbol. The cube root of m to the third is 3 divided by 3, m to the first. But we know that 1 doesn't have to be written. So we're going to bring down our next multiplication and then do the cube root of n to the sixth. 6 divided by 3 is an even 2. So we just get n squared. So this is actually a perfect cube, and it equals these things multiplied together. 8mn squared. All right, we've got one more example. Number 12, another cube root. And this works the same for fourth roots. I have no doubts that you will do great. So number 12, we'll split it up again. The cube root of 56 times the cube root of r to the 8th times the cube root of s to the 4th. So, one piece at a time. This guy is not a perfect cube, so we need to find the biggest cube, the biggest perfect cube that goes into 56, which is going to be 8. So we're going to break this down into the cube root of 8 times the cube root of 7. And I'm actually going to go ahead and finish. We're going to do 2. And then this is just going to stay the cube root of 7. And when we bring all this down, I'm going to bring it way down. So, the cube root of r to the 8th. 8 is not perfectly divisible by 3. So we're going to have an r outside with a power, and we're going to also have a cube root of r with some power. So 3 goes into 8 2 times with 2 left over. All right, so that's what this broke down into. Then we get our final multiplication sign. 3 does not go into 4 evenly. So we're going to have an s times a cube root of s, and we have to figure out the powers. 3 goes into 4 one time with 1 left over. We know that those 1s are unnecessary because they are understood, so I'm going to delete those. And we've got all the radicals as simplified as we can. So everything outside a radical gets multiplied together. 2r squared s. Everything under a radical gets multiplied together under a radical. Cube root 7r squared s. And that is your answer. Thank you guys for listening. Have a great day.